All right. So, I'm thrilled that I'm able for the second year in a row to welcome a new vehicle partner to the Uber Elevate network. This partner is developing a very unique all-electric vertical takeoff and landing aircraft that's focused on achieving both low noise and high cruise efficiency in a little bit different way than some of our other partners. And so I'd like to welcome Caden Stanzione and Martin Perea, who is the CEO and CTO respectively of Jaunt Air Mobility, onto the stage and introduce their new concept and talk a little bit about what makes it different and exciting for the Uber Elevate network. So, Caden and Martin.
Please welcome Martin Perrier, Chief Technology Officer, and Caden Stanzione, CEO, Jaunt Air Mobility.
So, I thought I'd start out, Caden, by asking you a question. So, in a nutshell, can you tell us just who is Jaunt and where have you guys come from?
Well, thank you. First of all, Eric, thank you for being here. We appreciate everything Uber has done. Martin and I and our whole Jaunt team, excited to be here. We are a relatively new company. We have been incorporated in April of this past year. However, we're steeped deep in a team that's very experienced in VTOL aircraft development with engineers, scientists, managers, pilots, and financial individuals. And what we have done is we basically have looked at Carter Aviation success with 3 flight test demonstration aircraft to vet out the technology. So we started off saying, can we meet the technology requirements necessary to execute the Uber urban air mobility mission? That was very important for us. So we needed to make sure that technologically we could meet the safety, the noise, and the mission requirements. So as a company, we first looked at the technology requirement and then also looked at the direct operating cost to make sure that was important. We also added our own technological factors to that, ride comfort, and we also wanted to take a look at, a clear path to certification. So when we did that, we came across the concept that this is very, very feasible. And Martin had been working for a couple of years in refining the slowed rotor compound technology, which was quite different than where we are today with our reduced rotor operating speed aircraft technology. And with that, we made a decision to acquire Carter Aviation, and here we are today.
Right. So, Martin, Mark just a few minutes ago told us that helicopters can't do our mission. But this isn't a helicopter, is it? Instead, it seems to be, what I find really interesting and intriguing about the technology that you guys have both acquired and continue to develop is that in a very real way, I think this is an illustration of the power of distributed electric propulsion that opens up new design, new variables, effectively, new degrees of design that you can actually take and do interesting things with that weren't possible, perhaps, with traditional propulsion technology. Do you agree?
Yeah. So I'll comment on that. So, Mark Moore mentioned earlier this afternoon that, the helicopter, really doesn't fulfill the requirements for the Uber mission. And so our aircraft, does have a large main rotor on it. It has a set of wings. And that's about, as close you can get to similarity from a helicopter and an airplane. So we do have a very low disk loading rotor system, which is very, very efficient in hover flight. And as you transition, from hover into cruise flight, the wings pick up the majority of the lift of the aircraft. The rotor is unloaded in flight, and we can reduce the speed of the rotor significantly, so it's a very, very quiet configuration. Very efficient with high lift-to-drag ratios. Another unique attribute of the aircraft, if you notice, there's no tail rotor associated with the aircraft. And the tail rotor is the second largest noise generator on a typical helicopter. And when you size the propulsors or the propellers for cruise flight, you end up with redundancy for any torque in a hovering condition. And so we do have the ability to provide anti-torque with any set of propellers, if you will, in low-speed flight. So we have a level of redundancy in the aircraft itself as a result of that. So this rotor, again, is not typical of a helicopter type of rotor. I know that Uber is very, very concerned about the direct maintenance costs, the DMC. And so the fact that we unload and slow the rotor down in flight, it allows us to look at design options relative to how you control collective and pitch. And so we don't have bearings and pitch links that you find in a typical rotor system. It's a very, very simple, clean design. It's a bearingless design. We're using elastomerics for pitch control. And that will allow us to, lower the maintenance costs and have very long periods, before inspection requirements. So we're pretty pleased with, with that design attribute. They should lower DMC inspection requirements, similar to a fixed-wing airplane, which is what you're looking for. So, all of these technologies really kind of combine into a very low-noise, high-efficiency aircraft. There's another element, this aircraft offers from a safety perspective. It is capable of, obviously wing flight like an airplane and rotorcraft flight. And so we have the ability to eliminate what they call the dead man's curve, or the HV avoid area in flight manuals. We have an ultra-high energy rotor system that provides, a degree of capability that you don't typically find in a rotorcraft.
Fantastic. So, Caden, it's pretty difficult, even for a large company, to develop a new electric VTOL aircraft. What is your perspective on how a startup like Jaunt is able to do that? How do you have a chance to do this?
Well, actually, we're following Uber's model. The idea is to reduce the risk by bringing in premium partners that will enable us to achieve our goals by following on the RDT&E investments that they have made that get us to where we need to be. So, for example, as we take this multi-pronged risk reduction approach, we couple that with a strong management team and relationships across working with Uber and the Uber design team, which has been absolutely wonderful in helping to really specifically define the requirements so that we don't over-design or under-design. And we've partnered with Honeywell and Triumph. This has become key because what happens is Honeywell has a huge investment in the digital components of the aircraft. So if you look at the aircraft from tip to tail, we really reduced the number of participants, which actually reduces the risk because we have less integration problems. From tip to tail externally on the aircraft, everything that you see structurally is provided by Triumph. That helps us. Triumph has had a large investment in advanced structural materials. They have the design capability. Again, those cost savings get passed down to us. Internally, inside the aircraft, again, from tip to tail, we've selected Honeywell. This is an all-digital aircraft for the most part, from avionics to the flight deck to the flight management computers, fly-by-wire, the electric motors, motor controllers. It's one complete integrated digital aircraft. So when we do this and we take a look at this, we have a much lower risk, compounded because the key technologies in slowing the rotor down has already been achieved. When we originally looked at the aircraft, the technology readiness levels were already high enough that we didn't have to invest a tremendous amount of money. So as we detail our plans right now, we have our work to do. We're actually scheduled to meet with Honeywell, Triumph, and our team and our financial team to work together to come up with a very intricate cost plan, and we're working with Price Systems that is the honest broker in helping us understand that we've included all the price elements and that we understand that what we need to do is to make sure that all the components are properly integrated right through the full life cycle. Other than that, where we stand now, we've been fortunate, we're self-funded, we're sufficiently funded to get us to the next level.
Fantastic. So Martin, you have a pretty impressive prior history. You were at Bell, you led several of their helicopters through certification, kind of a long, illustrious career there. But you certainly know, as a result of that, how difficult it is to certify even a conventional aircraft. One of the reasons we were partly attracted to partnering with Jaunt is because you have a little bit of a different approach to certifications than some of the others in the eVTOL ecosystem. Could you share what your thoughts are on that and what your approach looks like?
Sure. Yes, and we've been thinking a lot about this here recently, and we have engaged the authorities relative to putting that plan in place. It's still obviously a plan in work. So if you look at the FARs today under Section 1.1 under general definitions, you will find the definition of a gyrodyne. And actually, our aircraft fits the definition of a gyrodyne, which happens to be a rotorcraft. A helicopter is actually a rotorcraft, and a gyroplane is a rotorcraft. And of course, we power the rotor full time in flight. And so, rotorcraft are actually certified under Part 27 and Part 29. And so we're going to go down the path of certifying this particular aircraft with Part 29 requirements. We are going to set the bar in terms of certifying this thing as a transport category aircraft. We believe we can get performance class 1 from the aircraft because of its unique design features and the redundancy that we have in the electrification. And the fact that our rotor, acts as a spare engine, if you will, upon certain engine failures. So we are going to, set that up with the authorities. What I like about that aspect of it is the fact that the authorities are familiar with the method of compliance. The engineers are familiar with the design requirements for Part 29 aircraft. And we believe that we can get through, certification quicker than, some of the discussions that took place this morning under Part 23, which hasn't really been fully defined yet. We will, handle, the special conditions that are written against the aircraft. The fact that it is a winged aircraft, and there hasn't been a Rotodyne certified in a few decades. And we are going to, obviously use the rigor of, ARP 4751 and 4761. I'm a big, believer that drives your entire design, your configuration of the aircraft, and so that's the plans today. We are going to be building a, full-scale flight demonstrator. We're working on an integrated master schedule right now with Triumph and with Honeywell, and we expect to have that demonstrator flying in the 2022 timeframe. Really, it's a technology demonstrator to demonstrate the performance of the aircraft, both in payload range and the acoustics. We'll use it as a test bed to mature some of the technologies, and then we'll develop, 4 flight test aircraft for the certification program, which we are planning on entering in the 2023 timeframe, and then get through a certification program and try to get the aircraft certified in 2025 with production, following shortly after.
Super interesting. I think that this is a really, like I started with, really a fantastic illustration, again, of these additional degrees of freedom that arise when you start to change the propulsion system in an aircraft. And I'm really excited to partner with you guys because you're taking a bit of a different approach to the problem. And we don't know what the right answer is yet. And I'm excited to have partners that are working on this problem from several different perspectives, and I want to have many different vehicles that we can operate on our network in just a few years. So thank you so much for partnering with us, and look forward to be working with you for many years to come.
Yeah,
Same here. Thank you
Appreciate
very much.
Thank you very much.